What's up, everyone? It's Miles here from bootcamp.com, and today in pulmonology, we're going to be going over pneumoconiosis. So first we'll start off by talking about pneumoconiosis basics. So the basic principle of pneumoconiosis is that at certain occupations, we can inhale certain dust particles, and then many years later, after we inhale these dust particles, we can start to see a disease process develop. And the basic pathogenesis of what's occurring in the lungs is that these dust particles, once inhaled into the alveoli, will be phagocytosed by alveolar macrophages, and then those macrophages are going to release cytokines, which is going to result in inflammation and fibrosis. So if we just take a look at the diagram in the left corner of the screen here, we can see that when dust enters the alveoli here, that's going to get phagocytosed by macrophages, and then those macrophages are going to release cytokines, which is going to result in inflammation and fibroblast activation with subsequent fibrosis. And depending on what dust particle is inhaled will determine the different features that we're going to see in the pneumoconiosis. So the first pneumoconiosis that we're going to talk about is coal miners' pneumoconiosis. And as the name suggests, this is usually seen in coal miners. And so what we're going to get is inhalation of coal dust or carbon particles. And then on histology, what we're going to see is blackened carbon-laden macrophages. So as the macrophages phagocytose those carbon particles, they're going to get a black appearance to them, and this is called anthracosis. So if we just take a look at this histology picture here, we can see these large black pigments here, and this represents macrophages that have phagocytosed coal dust or carbon particles and now have a black appearance. So the next pneumoconiosis that we're going to talk about is silicosis. And the classic occupations associated with silicosis are sandblasting and working in foundries where we have metal production. So what's occurring here is we're getting the inhalation of silica particles, and this is going to lead to lung nodules and eggshell calcifications in the hilar lymph nodes. And so if we just take a look at this chest x-ray here, so these regions right here represent where the hilar lymph nodes are located, and we can see these calcifications present that resemble eggshells. And furthermore, when silica particles are phagocytosed by macrophages, they tend to cause macrophage dysfunction, and macrophages are really important for containing and preventing tuberculosis infection. So in silicosis, when we have macrophage dysfunction, this is going to increase the risk of a tuberculosis infection. Okay, the next pneumoconiosis that we're going to talk about is berylliosis. And the classic occupations associated with berylliosis are aerospace manufacturing and beryllium mining. And so what we see in berylliosis is after we inhale beryllium, this is going to lead to non-caseating granulomas in the lung, and we're also going to see some enlarged lymph nodes. And furthermore, berylliosis is associated with an increased risk of lung cancer. All right, so now we're going to finish up by talking about asbestosis. And asbestosis is really high yield and really commonly tested. And the classic occupations associated with asbestosis are roofing, shipbuilding, house insulation, especially old houses where they used a lot of asbestos in the insulation, and plumbing. And what you really want to understand about asbestosis is that when we inhale asbestos fibers, this is going to affect the lungs and the pleura. And so at the level of the lung, what we're going to see is fibrosis and bronchogenic carcinoma. And at the level of the pleura, we're going to see these calcified pleural plaques. This is a super high yield finding. We see these calcified pleural plaques. And we're also going to see pleural effusions. So if we just take a look at this CT scan here, we can see just on the edge of the lungs, we have this white opaque structure. This is a calcified pleural plaque. And if we just take a look at this chest x-ray here, we can see that at the bottom edge of the lungs, we have these white calcified pleural plaques. And so in a question on asbestos, I would really look at these two areas to check for pleural plaques. Okay, so another high yield finding that we can see in the pleura is something called mesothelioma. This is a cancer of mesothelial cells, usually in the parietal pleura, and asbestos is one of the only risk factors for mesothelioma. And so now it's important to point out that inhaling asbestos fibers will impart a risk of getting both lung cancer or bronchogenic carcinoma and pleural cancer or mesothelioma. And one thing that some board examiners want you to know is that in asbestosis, getting a mesothelioma is less common than getting a bronchogenic carcinoma. So if you have asbestosis, you're more likely to get a bronchogenic carcinoma than getting mesothelioma. Okay, and a classic pathological finding in asbestos lesions is something called ferruginous bodies, which are described as golden fusiform iron-coated fibers. And so if we just take a look at this histology image here, so we can see this fiber right here is a ferruginous body. We can see it's fusiform in appearance and coated with iron, and I like to think of it kind of as a brown Q-tip looking structure. And finally, I just wanted to point out that different pneumoconioses will affect different portions of the lungs. So typically, coal miners, silicosis, and berylliosis will all be affecting the upper lobes of the lungs, whereas asbestosis typically affects the lower lobes of the lungs. Okay, so now let's just summarize a few key points from the video. So a pneumoconiosis is when we inhale certain dust particles, usually from certain occupations, and then many years later, so maybe 10 to 20 years later, we'll start to see disease. In coal miners' pneumoconiosis, we're going to see those black carbon-laden macrophages. In silicosis, usually sandblasters or foundry workers can get nodules in the lungs, as well as eggshell calcifications in the hilar lymph nodes, and furthermore, they can get an increased risk for tuberculosis. Berylliosis, people that work in aerospace manufacturing or beryllium miners can see non-caseating granulomas and enlarged lymph nodes in the lungs, as well as they can get an increased risk for lung cancer. And lastly, in asbestosis, roofers, shipbuilders, house insulators, and plumbers are going to see disease in the lungs and the pleura. In the lungs, we can see fibrosis and bronchogenic carcinoma, whereas in the pleura, we can see those calcified pleural plaques, the pleural effusions, and mesothelioma. And furthermore, in the asbestos lesions, we're going to see those iron-coated fusiform-shaped rods called ferruginous bodies. All right, and that's all we got for our video on pneumoconiosis.